Welcome to WikiPodcast, where we take a deep dive into the lives and discoveries of history's most impactful figures.
Hmm.
Today, we're unpacking the extraordinary story of a true scientific genius, a woman whose work fundamentally reshaped our understanding of the universe and paved the way for modern medicine, Marie Curie.
What a story it is.
Get ready to explore a journey of unparalleled scientific discovery, immense personal sacrifice, and, well, the profound impact of radiation that shaped the modern world.
It's truly an incredible story, one that goes beyond just the scientific breakthroughs. It reveals remarkable human resilience.
Absolutely.
When we think about figures who truly changed history, Marie Curie really stands out. Not just for her huge contributions to physics and chemistry, but for the sheer determination she showed, overcoming just immense personal and professional obstacles.
Definitely. And to really get her journey, we have to go back to her beginnings. Warsaw, which was then part of the Russian Empire, November 7, 1867.
Right.
Born Maria Salomea Skłodowska. She was the youngest of 5 kids, children of well-known teachers, but life wasn't easy for them.
No, far from it. Her family had actually lost property in earlier Polish national uprisings. That set a pretty challenging stage, didn't it?
It really did.
And that challenging start, well, it got deeper with personal tragedy. Her father, Władysław, taught math and physics. He even brought lab equipment home after the Russian authorities took it out of schools.
Wow.
So she had this incredibly early, hands-on science exposure. But even with that intellectual nourishment, sorrow was kind of a constant.
Yeah.
Her oldest sister, Zofia, died of typhus. And then her mother, Bronislawa, died of tuberculosis when Marie was just 10.
Only 10.
Yeah, these huge losses affected her deeply. It actually led her to become agnostic.
Can you even imagine that resilience building up so young, facing that loss? And then at 15, she graduates secondary school with a gold medal.
Top of her class.
But then she spends a year recovering from what might have been depression. And talk about systemic barriers. Because she was a woman, she couldn't enroll in regular higher education.
Right. The universities were closed to women then.
So she attended the clandestine flying university. It was a secret, patriotic, Polish institution that admitted women. That says so much about her thirst for knowledge, doesn't it?
It really does. And what stands out is the extraordinary lengths she went to. She made this pact with her older sister, Bronislawa.
Ah, the pact. Yes.
Marie would basically work and send money to support Bronislawa's medical studies in Paris.
Okay.
And the deal was Bronislawa would help Marie out 2 years later.
That's incredible sibling dedication.
Totally. So Marie worked tirelessly, home tutor, governess, saving every penny. And it was during this time, as a governess, she fell in love with Casimir Zurawski.
Oh.
He later became a really eminent mathematician. But his parents rejected the marriage because she didn't have wealth.
Heartbreaking.
Yeah. It's quite poignant. Apparently, years later, he was often seen sitting sort of contemplatively by her statue in Warsaw.
Wow. That unfulfilled love story just adds another layer to her drive, Even with that setback, she just kept going. Self-education, reading, tutoring. And she even started practical scientific training in a chemistry lab at the Museum of Industry and Agriculture in Warsaw.
That foundational period, full of hardship, but also this relentless intellectual pursuit, it really set the stage, didn't it?
It absolutely did, forging that rigor and tenacity.
Exactly. Which she definitely needed for what came next.
And that next chapter kicked off in late 1891. She finally moves to Paris, adopts the name Marie, and she lived incredibly frugally, like in a garret, a tiny attic room.
Barely scraping by.
Focusing intensely on physics, chemistry, mathematics at the University of Paris. Apparently, she was sometimes so focused she forgot to eat.
That's dedication, almost a monastic commitment to learning.
Right. She earned her physics degree in 1893. Then got a fellowship, managed a second degree in 1894.
And she started her scientific career proper, investigating the magnetic properties of steel, kind of setting the groundwork.
And it was then, 1894, her path crossed with someone crucial, Pierre Curie.
Oh, yes, Pierre.
They were introduced by a mutual physicist friend. Marie was looking for a larger lab space, apparently, but it was their shared passion for science, that intellectual spark, that drew them together instantly.
A real meeting of minds.
Pierre proposed. Marie initially thought about going back to Poland.
Right, she was still very attached to Poland.
But she accepted, partly because Pierre was willing to move to Poland for her. That must have been quite something.
It showed his commitment, definitely. So they married July 26, 1895. No religious service, neither wanted one.
Very modern for the time.
Yeah, and her dark blue wedding outfit, she actually wore it as her lab coat for years.
Practical.
In Pierre, she found not just a life partner, but, well, an unparalleled scientific collaborator, someone she could really rely on.
And that partnership led straight to these groundbreaking discoveries that just shook physics to its core.
It started with inspiration from others, didn't it? Wilhelm Röntgen discovered X-rays in '95.
Right.
Then Henri Becquerel found uranium salts emitted similar mysterious rays in '96.
So Marie chose those uranium rays for her doctoral thesis. She used a special tool, an electrometer, developed by Pierre and his brother.
Which was crucial. It could measure the really tiny electrical charges these rays produced.
And her first big finding. It was revolutionary. She found the activity of uranium compounds depended only on the amount of uranium present.
Think about that. Just the amount, not the chemical form or temperature or pressure.
Which led her to this incredible hypothesis that the radiation came from the atom itself.
Which completely challenged the idea that atoms were these solid, indivisible things. Suddenly the atom wasn't a tiny billiard ball, it was active, dynamic, a source of energy.
A seismic shift in thinking. And then, in 1898, she found thorium was also radioactive.
And Pierre was so fascinated by her work, he just dropped his own research on crystals.
Just like that.
Yeah, to join her. They started working together in this pretty basic shed. Poorly ventilated, not even waterproof.
And they had no idea about the health risks of radiation, did they?
None at all. They apparently carried radioactive samples in their pockets, like the way they glowed faintly in the dark.
Oh, wow. So they systematically studied minerals like pitchblende and torbernite.
Right, uranium ores, and they found these were way more radioactive than pure uranium should be.
Which suggested.
There must be other unknown, highly radioactive elements hiding in there.
So July 1898, they jointly announced polonium.
Named after Poland, Marie's homeland. A very deliberate, patriotic act, since Poland was still partitioned then.
And then, December 26, 1898, they announced a second element, even more potent.
Radium, from the Latin word for ray, and they also coined the term radioactivity itself.
But announcing them was one thing. Isolating them was something else entirely.
Oh, absolutely. The truly backbreaking work was just starting. They had to process tons of pitchblende ore.
Tons, literally.
Literally tons. Grinding it, dissolving it, filtering, crystallizing, over and over for years in that shed.
The sheer willpower. Just incredible. They finally isolated about 1/10 of a gram of radium chloride by 1902.
And pure radium metal only in 1910. Polonium, though, its half-life is really short, just a few months.
Meaning it decays quickly.
Exactly. So they never managed to isolate in pure form. It just disappeared too fast.
Between 1898 and 1902, they published, 32 scientific papers?
Astonishing output, including one paper noting that radium seemed to destroy diseased, tumor-forming cells faster than healthy ones.
A really early hint at radiation therapy.
Decades before it became common. And Marie also became the first woman faculty member at the École Normale Supérieure in 1900. Then in June 1903, she got her doctorate from the University of Paris.
What an intense few years. And then came the Nobel Prize.
Yes, the 1903 Nobel Prize in Physics, awarded jointly to Pierre Curie, Marie Curie, and Henri Becquerel for their work on radiation.
And Marie was the first woman ever to win a Nobel Prize. A historic moment.
Absolutely huge. But, it almost didn't happen for her. The committee initially planned to only award it to Pierre and Becquerel.
Seriously, they were going to exclude her.
Yes. It highlights the sexism she faced, but Pierre insisted. He said he wouldn't accept it without her.
Good for him. That took integrity.
It really did. They actually declined to go to the ceremony initially, said they were too busy and Pierre wasn't well. But the prize money was vital.
Ah, right. Practicalities.
It let them hire their first lab assistant. A big help.
Then, in December 1904, their second daughter, Eve, was born. Marie always made sure her daughters learned Polish, visited Poland. She kept that connection strong. But then, tragedy. In 1906, Pierre was killed.
Just awful. A street accident, hit by a horse-drawn vehicle. Marie was absolutely devastated.
How did she even carry on after that? Losing her partner, her collaborator?
It's hard to fathom. But her commitment to their work, to his legacy, it must have driven her. On May 13th, 1906, just months later, the University of Paris offered her the physics chair that had been created for Pierre.
And she took it.
She did, becoming the first woman professor at the University of Paris. Her goal was clear: build a world-class lab as a tribute to him.
Which eventually became the Radium Institute.
Exactly, the Institut de Radium, a joint project with the Pasteur Institute, created for her in 1914.
And her own work continued at an amazing pace. 1910, she isolates pure radium metal.
Yes, and she defined the international standard for radioactive emissions, which was eventually named the Curie in their honor.
But even with this incredible fame, the sexism and xenophobia didn't stop, did they?
Not at all. The French Academy of Sciences famously failed to elect her as a member in 1911 by just 1 or 2 votes.
Unbelievable, after everything she'd achieved.
And then her personal life became fodder for scandal. In 1911, her affair with physicist Paul Langevin, who was married but separated, was revealed.
Oh dear. The press must have had a field day.
It was vicious. They painted her as this foreign Jewish homewrecker, playing on xenophobia, anti-Semitism. It was brutal.
Yet, despite all that,
the Royal Swedish Academy of Sciences awarded her a second Nobel Prize in 1911, this time in chemistry.
wow, for the discovery and isolation of polonium and radium.
Making her the first person ever to win 2 Nobel Prizes, and still the only person to win in 2 different scientific fields, physics and chemistry.
That's just monumental, but the scandal almost overshadowed it.
The Nobel Committee chair actually tried to get her not to come to the ceremony in Stockholm because of her supposedly questionable moral standing.
What did she do?
She went anyway.
Yeah.
She insisted, quite rightly, that the prize was for her scientific work and her private life was irrelevant.
Good for her, standing her ground.
And that second Nobel, well, it gave her the clout she needed to persuade the French government to properly fund the Radium Institute.
So she turned that adversity into momentum for her science. Incredible strength.
It truly is. Her focus was unwavering.
And then came World War I. Her contributions shifted again, didn't they? Right to the front lines, in a way.
Absolutely. She saw the urgent need for X-rays to help wounded soldiers, so she developed mobile radiography units.
The famous petites Curies, little Curies.
Exactly. She didn't just have the idea, she made it happen. She quickly studied radiology, anatomy, even car mechanics.
Car mechanics.
Yeah, to maintain the vehicles. She got equipment, trucks. She became the director of the Red Cross Radiology Service.
Setting up France's first military radiology center.
Yes, and overseeing 20 mobile units plus 200 radiological units in field hospitals. She even trained other women as aides.
Empowering others while saving lives.
And she used her own radium supply, too. She provided radium to make hollow needles filled with radium emanation, what we now call radon gas.
What were they for?
For sterilizing infected tissue and wounds, directly applying her discovery.
It's estimated over 1 million soldiers were treated with her X-ray units.
A staggering impact. She even tried to donate her gold Nobel medals to the war effort.
Did they take them?
No, the French National Bank refused them. But she bought war bonds with her prize money instead.
Yet, despite all this humanitarian work,
She never received any formal recognition from the French government for it. She later wrote about it in her book, Radiology in War.
that seems incredibly unjust.
It does. After the war, she kept working. Toured the U.S. in 1921 to raise funds for radium research. President Harding actually presented her with a gram of radium at the White House.
A gram of radium. That must have been incredibly valuable.
Immensely. Later, the French government offered her the Legion of Honor.
And she?
She refused it. She stayed focused on science, became a fellow of the French Academy of Medicine, worked with the League of Nations Committee on Intellectual Cooperation alongside people like Einstein.
And her Radium Institute flourished under her leadership.
It really did. It produced 4 more Nobel Prize winners, including her own daughter, Irene Joliot-Curie.
Like mother, like daughter. And she helped establish the Warsaw Radium Institute, too.
Yes, her second U.S. tour in 1929 helped equip it. It opened in 1932, and guess who was its first director?
Her sister, Bronislawa.
Bronislawa, the sister she'd made that pact with all those years ago. A wonderful full circle moment.
It really is. But the science she dedicated her life to, it ultimately cost her dearly.
Tragically, yes. Marie Curie died on July 4th, 1934. She was 66. The cause was aplastic anemia,
Which is?
a condition where your bone marrow just stops producing enough blood cells. It's now widely believed it was caused by her long-term exposure to radiation.
From all those years of research, handling materials without protection.
Exactly. And her intense X-ray work during the war, the dangers just weren't understood back then. She carried test tubes of radioactive stuff in her pockets, kept them in her desk.
The heartbreaking irony, the thing that made her famous, that helped so many.
It was also slowly killing. In 1995, her remains were moved to the Paris Pantheon.
A huge honor in France.
And she was the first woman interred there based on her own merits. Her coffin had to be lined with lead because her body was still radioactive.
Still radioactive, even after all that time.
Yes. And her notebooks, her papers from the 1890s, They're still highly radioactive today. They're
Wow.
kept in lead-lined boxes. If you want to consult them, you have to wear protective clothing. Her work literally left a physical, lasting mark.
Her legacy is just immense, isn't it? Her work didn't just add to science, it changed the foundations of physics, led to understanding the atom, nuclear energy.
And gave us crucial tools to fight cancer, revolutionized medicine. Plus, think of the barriers she smashed as a woman in science in Poland and France.
And her character shines through too. Her honesty, her moderate lifestyle, returning scholarships, donating Nobel money.
And perhaps most remarkably, refusing to patent the process of isolating radium.
Why did she do that? She could have been incredibly wealthy.
She believed scientific knowledge belonged to everyone. She wanted the scientific community to research it freely, unhindered by patents. She felt it would speed up progress, especially medical applications.
That's incredibly selfless, prioritizing discovery over profit.
It's why Einstein reportedly said she was probably the only person who cannot be corrupted by fame.
What a tribute. Her legacy lives on everywhere. The Curie unit, the element curium, institutes, universities, banknotes.
A powerful testament to the relentless pursuit of knowledge, no matter the cost, no matter the barriers.
And that concludes our deep dive into the extraordinary life of Marie Curie, her journey from a hidden university in Warsaw to becoming a double Nobel laureate, changing the face of science and medicine. Well, it's truly inspiring.
Absolutely.
Thinking about the immense obstacles Marie Curie overcame, what aspect of her journey do you find most inspiring?
That's a great question for our listeners.
Thanks for listening. Write us your opinion in the comments. Subscribe to the channel to help more listeners reach our episodes. Thank you and have an amazing day.